Hi, welcome to Learning Electrical Engineering channel. In this video, we will see series connection of inductors. For that, we will have a circuit which has one voltage source V and n number of inductors connected in series as shown in the diagram. The amount of current flowing through all the inductors will be remain same and voltage drop across each inductor will vary. That is, voltage drop across L1 will be V1 and L2 will be V2, L3 will be V3 and up to Ln, the voltage drop across Ln will be Vn. To find out the equivalent inductance of the circuit, we need to apply the Kirchhoff's voltage law. Kirchhoff's voltage law is stating that the algebraic sum of a closed loop voltages is equal to 0. Now we will apply the Kirchhoff's voltage law. For that, we will draw a loop like this. And we will mark the arrows. This is the loop arrow direction. Okay, the arrow may be in either of the direction. The value of the resultant value will be same. Now the loop arrow initially meets the V1 positive potential, so we will take V1 is positive as per Kirchhoff's voltage law. V1 is positive, so we will write V1 is positive, and same manner the arrow next meets the V2 positive potential, so we will take V2 is also positive. And if you are seeing from the circuit diagram, the arrow meets initially all the voltage drops positive potential, so we will take all the voltage drops is positive V3 and up to Vn. And finally the loop arrow meets the negative terminal of the voltage source, so we will take the voltage source is negative, which is equal to 0. On further simplification, the negative voltage term can be transferred to the right hand side of this equation, so the equation will become V is equal to V1 plus V2 plus V3 and up to V plus Vn. Say this is the equation number 1. We need to apply the value of V here to find out the equivalent inductance of this circuit. For that, we know one formula: V is equal to L into di by dt. So we are going to apply this formula into equation number 1. For the V is the circuit source voltage, so for that I need to know the equivalent inductance. So I will write equivalent inductance value L equivalent into the current in the series circuit is same, so I will write this equation di by dt as it is, and which is equal to the voltage drop across L1 will be V1, so we will write inductance value is L1 and the current through all the inductances will be same, so we will write the current term as it is di by dt, and we will apply the voltage formula for all the voltage terms, so the voltage terms can be replaced with the inductance times variation of current with respect to time, so L2 into di by dt plus for V3 we can write L3 into di by dt and up to Vn, that is Ln into di by dt. Now we can take out the common value in all terms outside of the bracket, so L1 plus L2 plus L3 and up to Ln into di by dt. The left hand side of this equation we can write as it is, dl equivalence into di by dt. So the L equivalence, the equivalent inductance value will be summation of individual inductances values in the series combination, L1 plus L2 plus L3 and up to Ln. Ln. Okay. Now from this equation we can come to a conclusion that in a series circuit the equivalent inductance will be the summation of individual inductances values, which is same as the resistors in series. If the circuit is having n number of inductances with equal inductance value, that is L1 is equal to L2 is equal to L3 and up to Ln is having only one same inductance value, that is L, that time the equivalent inductance will be n into inductance value of one inductor. So this n will be number of elements connected in the series combination, and the equivalent inductance of a series combination will be greater than the greatest value of inductance connected in the series combination. If you have liked this video, kindly hit the like button, and if you have not subscribed my channel, kindly subscribe it. If you have any doubt, kindly write on the comment box. I'll reply. Thank you so much.